अस्सलाम वालेकुम व्यूअर्स। आज के इस लेक्चर में हम विप और नेट पूल्स के बारे में पढ़ेंगे। सोर्स नेट, डेस्टिनेशन नेट, विप कहाँ पे यूज़ की जाती है और स्टैटिक जो पोर्ट बाइंडिंग का कॉन्सेप्ट है, पब्लिक पोर्ट पब्लिशिंग का जो कॉन्सेप्ट है, विप कहाँ पे यूज़ करेंगे, आईपी पूल कहाँ पे यूज़ करेंगे फॉर नेटिंग पर्सपेक्टिव। तो चलिए जी उसको देखते हैं। हमारी टोपोलॉजी जो कि हमने एसडी वैन के लिए यूज़ की थी, सेम टोपोलॉजी है। फॉर एग्जांपल यहाँ पे यू कैन सी वी हैव अ 3 राउटर्स and we have 2 VLANs. This VLAN is VLAN 200. This is V200 and size is too high. Let me small this size. 20 is enough. Okay, this is VLAN 200 and this is my VLAN 220. The target from this diagram, we will create the VIP IP pools, VIP virtual IP. The concept for virtual IP, actually when we want to access any internal system from outside, means if I want to access this machine from this outside world, I need to create a virtual IP. We need to configure the VIP on FortiGate. We will bind the public IP that is coming from outside world at FortiGate, and it will bind to virtual IP, local IP. It's basically binding from public IP to private IP binding. Same like we will configure a one VIP from this router to this PC1. Okay, and we will create another VIP, that is source will be our router 2 and its IP is 2.202.1, and it will go to the FortiGate. The VIP will translate its binding toward PC2, and PC2 has IP address of 192.168.200.x. Okay, and last we will create the third VIP that will be binded with PC3. So we will open the specific port we can also customize the port that should not be compromised, although it can be compromised, or it can be have a clear idea from outside by nmap, but we can control by IPS applying on this outside policy. Okay, this is the VIP side portion, and after that we will configure the NAT from source to destination. Means these two VLANs are our source, and when their traffic goes outside, so what IP will be NAT on FortiGate? The session will create a new session, and when IP is coming from, let me show you, 192.168.200 and let's say 121 is my source PC1 source IP, and it's a PC1, and it want to go 8.8, destination is 8.8. So when the traffic will come on the firewall, it will check the source IP, and it will translate to it will change the source IP as the new packet will generate and new packet have a source IP as 192.168.201.x and destination will remain same 8.8.8. Okay, this is the NAT binding. When traffic is coming from the LAN side and will go to outside, it will NAT on a different IP and will communicate in the internet world. Also, the private IP is not routable on the internet, so that's why we must have to NAT our internal subnet on public IP, and then we can reach on the internet. So let's start our lab. First we will configure the VIP and then we will configure NAT and we will look at the NAT types. Okay, this is our topology. Sorry for that. This is our topology, and we can check that we have a internet access on all the LAN systems. Okay, and PC1, yes, internet is reachable. So now I want to access this outside world. Let's say telnet 192.168. I want the access of internal PC1, and PC1 IP is I don't know what is the PC1, but I will come from this port 1. So firewall's port 1 IP, and that is firewall port IP is 201.2. Okay, there is no response because outside port is not listening on anything else. So we need to configure a VIP. First we will create an object and we will call this VIP object inside at apply at the policy. So this is my virtual IPs. One VIP is already configured, and let's look into it. It's a R1. Let's say ISP1, ISP R1 to PC1. Okay, so its interface, listening interface is ISP1. In my case, it's ISP1. At firewall, port 1 is responding corresponding to ISP1. So that's why I chose ISP1. And external IP is my router IP, ISP201.2. You can select any of IP from the subnet pool. And what is my LAN IP? LAN IP is my local PC's IP. So my PC IP is it's a PC1. Show IP interface brief. It's a 200.204. So it's binded. This IP is mapped to this internal or private IP, and also we can specify what source is coming from outside world. So we know that only this subnet is coming from outside world because this point-to-point subnet. It's not a point-to-point; it's a /24. But we know that actually this subnet is coming, and from this router, and the traffic will be generated to access the internal client PC1. So we can restrict the subnets here who can have the permission to come inside. And what is the service? We can also bind at 23. Then okay, and let's configure for PC2 as well. it's router 2, and it will access to PC2, and this time ISP2, and let's configure will remain same 2, and this time my PC2 IP enable Cisco mm, show IP interface brief, and it's a 205 200 205 205, and this time PC ISP2. Okay, we can change any color if you want, and optional it's this time it's a 202 ISP2, and this time I will not allow to SSH I will not allow to telnet. I will allow only SSH service, SSH as well as ping, and ISP ICMP, all ICMP. Okay, and I will remove the telnet service. Okay, so and ISP1 from router 1 I can telnet PC1, from router 2 I can ping PC2 as well as I can SSH PC2, and from PC3 I will access the PC from ISP3 I will access the PC3 as only service SSH. Okay, let's configure the last one, clone, and it's a router 3 ISP3 to PC3 and port number 3, because traffic will generate from behind the port 3, and external IP will be 203 dot, let's say 10, and 200 dot, let me check the PC3 IP, PC1 PC2. Okay, PC3 is not, don't have the access. This is our PC3 of VLAN 2. VLAN 2 enable configure terminal. We have to configure this in client. Configure terminal interface is 0, IP address DSCP, no shift, exit IP route 0000 and 192.168.200.1, hostname PC3 V200, and right. Check the internet is working or not. Internet working is not our requirement in this lab, but just for knowledge, yeah, it's working. So let me check the IP, show IP interface brief. It's a 206, so we need to bind 206 instead of 205, and this time only SSH is being allowed. Okay, you can also port forwarding here, 1 to 1, 1 to many, all these ports you can, all other parameters you can manage from here. Let's say you can close this one, and only port forwarding 22.22, we can do that also, or services SSH, these all the, also we can restrict these options from IPv4 as well as from the port mapping also. Okay, we have 3 VIPs configured. Let's call and apply on the IPv4 policies. Excuse me. Source ISP1 to PC1. Okay, and source is outside WAN. Yes, because the port 1 is part of the SD-WAN, and it will go inside the VLAN 200 and VLAN 220. The same logic is SD-WAN interface, because as secure zone has all two internal VLANs. So this time source will be VLAN 200, no, ISP1. This time source will be ISP1. ISP1 subnet mask need to change. It's not /20 /30, it's at 24. Okay, ISP1 201. Subnet not changed, I think. Let me check again. Okay, yeah, it's changed. It's not. It's a naming issue. Okay, and source ISP. But anyhow, it's inside this name. It's working fine, and destination is ISP router 1 PC1. This is binded to service all. It's just for knowledge that we cannot access this service all. Means it does not mean that we can access any service of internal PC, because we have restricted the services inside the this binding, so it will not allow any other services. Okay, entry not found. It means this object is not found. ISP1. It's still not found. Okay, let's create a new object with the ISP1 192.168.201.0/24. Duplicate entry found. Control V. Okay, and there you go. Okay, this time it's /24/201, and this router is belongs to 201, and destination is 202. That is a firewall, and firewall will net internal net and will transfer the traffic to PC1. Now it will be saved. Okay, let's configure uh, for PC2 as well. Paste below ISP2 to PC2, ISP2 to PC2. Apply. All main LAN and WAN interfaces will remain same except the objects. ISP2 is 202, and the mapping ISP2 is, yes, this one. Service, this time only SSH service should work, but I'm selecting all. We will check that other services will not working. and let's enable this policy. Enable. And finally the third one is paste below, and ISP3 to PC3, apply. Change the source and destination objects. ISP3 is this one, yeah, 203, and change the binding, I mean VIP. This is called VIP, and it's also called destination netting. Services all, and all sessions, enable this policy, yes, and save. So let's check the output from ISP1. What is enabled in ISP1? We enabled the service. Let me show you. The ISP1 is eligible to access the telnet, I think only. Yeah, only telnet. Let's SSH -L first. -L PC1, and the IP address 192.168. Public IP of firewall, that is 201.2. It should not respond because we have not allowed the SSH service in this binding. So ISP router 1 coming from outside world and will hit to firewall outside IP, and this will allow only for telnet service, so it will not respond. Let's stop this. We have to wait for, and let's check the second policy behavior. Second policy is allowed for ping as well as SSH. Yes, its SSH is also there. Second one, yeah. And first one, let's complete the output. First one also. Telnet 192.168.201.2. There you go. And Cisco is PC1. Password is Cisco. Yes. Show IP interface brief. Okay, we have accessed the LAN internal system from outside world with the help of this binding. We can also the logs at policy 1. There must be a logs. Yes, we have received the logs. Show matching logs. It took time. We have to wait a little bit, and we can check the urgent basis logs on FortiView. Okay, source is this one, 201.201.1 is router, destination is firewall, and TCP 23, and you can see there is no also there is nothing other services are reachable via outside interface, outside router, because we have binded inside the policy. You can also restrict from here. Best practices should restrict at both telnet, at both barriers. Okay, this time only telnet is allowed, although it's allowed only telnet earlier. Okay, let's check the second policy. SSH is allowed only. SSH -L and PC2 username and IP of firewall 192.168.202.2, Actually, I enabled the debugs. Cisco, and I have accessed the you all, I think. Exit you all. Oh, ISP2 you all. Yes, and SSH -L 192.168.202.2. Username is missing. PC2. There you go. Show IP interface brief. In 8.8.8. Okay, we have accessed the internal PC from PC2. Also, we can ping as well. Ping 192.168.202.2. This ping is responding the internal PC. This is not allowed on. I will show the interface ping. Yeah, ISP2 is not responding to ping state. This ping is responding to inside internal PC. Also, you can check. This is the internal PC output. 205, and let me show the debug. Cisco show debug. ICMP is on. Yeah, if I ping from ISP2, so PC2 should respond. PC2, yes. Okay, reply send to 20. Respond back to 205, and 205 is the internal PC. So IP interface brief. Okay, last testing, we have a last testing of ICM from the ISP3. Let's check also. SSH only, no ping. SSH -L PC3 and 192.168.203.2. Let me check. ISP PC3 has configured the ISP or SSH or not. Enable configure terminal. Enable password. Do show IP interface brief. It's a 206. Okay. Do show IP route. Yes, we have a route. Enable password Cisco, and let's configure the SSH. Username PC3, password CISC Cisco, and for SSH configuration we have to enable the IP domain name as well. Domain-name lab.com and crypto key generate RSA. it's a 1024 and line VTY 024 login local transport input SSH only. Okay, let's check from the ISP3. Still not responding. Okay, and let's check the connectivity ping 192.168.220.200.1. Yes, it's reachable. Show IP interface brief. It's a 206. Check the binding of PC3. VIP. We need to check the VIP of PC3. It's a 205. That's the issue. It should be a 206. Oh, and let's try this time. Also, we can check we are receiving the logs and hits on per VIP. We can check the hit count. So there is no hit count at VIP. This is the ISP outside router. Yes, still not. It's not good. Okay, let's check the IPv4 policy. Source one, this one is 203.0 and okay, this is the 203.10. Okay, let's check that 203.10 is reachable or not first. Or we can edit this by 202. Instead of 10, we can define 2. 2 is the live IP. Okay, and this time it must work. And Cisco enable Cisco. Okay, that's great. So all three policies are working, and these policies are working as a VIP mode. This is called VIP, and this is called also destination net. So we can restrict from here as well. ICMP, ping, and last thing is SSH. And this for this one we allowed only the SSH. Okay, now this time we can check the log as well. Yeah, we have received the logs also. So this is the source IP 202.1 and there is no NAT IP. For destination, when it is coming to firewall end, firewall is 202.2 and firewall outside IP 202.1 is router and port 2 having IP address of 202.2. So when 202.2 reaches at firewall and it is converting to PC2 200.205 and that is behind the LAN service VLAN. VLAN 200 is the part of this IP. This is the PC2 basically. Yeah, 200.205. So this is the whole scenario. The VIP works. So now we will move to the NAT and we will configure the NAT from LAN to internet. So there is an internet policy and there is a outside interface NAT configured. We will change this. NAT by default use outside interface, so I don't want to use the by default scenario. I will change it to I want to configure. I want when the traffic is coming, I will configure two different NAT. First, I will show you the what I have configured. This is the NAT pool range that is overloaded. Only one IP is need 203.111. All the source subnet, I mean when traffic coming from these PCs and comes here, earlier it was netted to this IP address or this IP address or this IP address. Right now it will not NAT toward this interface's IP address. Right now it will NAT to this IP address. So let's configure. We have to configure IP pool first. Then we need to apply this IP pool on the ACL. So for VLAN 200, I am using this pool. This is the 203. No, it's for ISP3, and this is the 203.121.201. Yes, this one. This one is belonging to ISP1 201.105. Okay, and session all. Okay, let's ping from the VLAN 200. VLAN 200 means any PC from VLAN 200. Enable Cisco show IP interface brief. It's a VLAN 200 and let's ping 8.8.8. Okay, so let's check where from is going through. Trace route, and it's not reaching, it's not completing the trace. Let me check the SD-WAN rule. Is there any SD-WAN rule configured? Network SD-WAN rule, and yes, we configured the SD-WAN rule. Net rule 200. Let's this one net VLAN 200 and let's say VLAN 200, and it is going via outside. It should be a ISP1. Let's configure ISP1 and okay. Okay, this time its trace has been successfully completed via ISP1 and ping should also work perfectly. So this is working fine, and this one 220, and it should be port 3. It should be go outside via ISP3. Remove the ISP1. Okay, and from the VLAN 220, this is the VLAN 220. Enable Cisco. Enable Cisco show IP interface brief. Yes, it's a 220. Let's ping 8.8.8. It's not going to the let me check the policy. There is no policy, I think so, for VLAN 220. Yes, it's only internet policy V200, and let's configure the internet policy for VLAN 220 VLAN. Copy and paste below. INT policy VLAN 220, and let's configure the net source net as a different pool. So we need to change the source as a VLAN 220, and destination will remain same. We need to change this one. For VLAN 200 we configured the 201.105 netted IP, and this time we will configure the overload, and this is the 203.111. All the things should be net at this IP. The user belonging from VLAN 220. Enable this policy. Okay, and let's check the output. This is VLAN 220 and ping. There you go. Yes, and trace. What trace is? Trace out. No, this is PC. Trace route 8.8.8. There you go. Yes, as you can see, this is going the outside, and then it is going via ISP3, like this. This is VLAN 220. Traffic is coming from VLAN 220. It is directly going to SVI gateway and goes to direct IP ISP3, because I have created the different rules, SD-WAN rules, as well as different NAT rules for VLAN 220. We have two netted pools, one netted pool for VLAN 200 and one netted pool for VLAN 220. So you can check here. This is the VLAN 200 internet, and this is going via ISP1 with different netted pool, and this is VLAN 220, and it's going via different ISP and also having different netted pool. So let's check the output as well. You can also check the output from command line interface. 192.168.140.131 admin. We have a template of the commands. Just copy and paste it into command line. There is, I think, multiple pings. We have to copy the output. Let's paste into the notepad. It's basically protocol this port 2. I think it's not clear, something different. Okay, from GUI we can check it. Show matching logs, and we have a clear idea what is the netting, what NAT is being used. Source is coming from VLAN 200 and NAT IP is 201.105. Okay, 201.5 we have defined in the IP pool. Let me show you IP pool, virtual IP pool, this one, and this NAT pool is designated for VLAN 200 and 201.105. And let's ping from the PC2 as well. VLAN CISCO Cisco. This is the VLAN 200 and PC2 ping 8.8.8. Address is PC2. Okay, and ICMP is enabled. Trace also, we should check the trace. Trace route 8.8.8. Yes, it's working as per our expectation. 201 ISP1, and then it is outside the world. So guys, let's wind up this session. I hope you have get the clear idea of what is the outside net, what is inside net, and let's meet in next session.